Hello, everyone. Welcome to today's mathematics session. My name is Justin, and today we're going to be learning about the foundations of mathematics, which is numbers, or otherwise known as number theory. So, just a bit of disclaimer before we get forward that this topic is suitable for middle or high school students, meaning from grade 7 to grade 12. And as such, the ability to do basic mathematic operations such as addition, subtraction, multiplication, division, exponents, fractions, as well as roots, including square and cube roots, are required. With that being said, let's get started. So, first of all, let's start with a question here. What are real numbers? So, a number is a mathematical object used to represent quantity, count, or measurement. So, when you see an equation like 2 plus 2 equals to 4, 2 is a number and 4 is also a number. Now, notice how I said real numbers here. There is another type of numbers called imaginary numbers, where they do not exist in our world. However, that will be covered in a future lesson. So now we're going to be focusing on real numbers or numbers that exist in our real world. So numbers such as 1, 5, 9, even decimals such as zero point 0.1, and negative numbers such as negative 100 are all real numbers. And there are actually a lot of different types of numbers that we're going to be exploring today. First is natural numbers. So, what are natural numbers? These are known as counting numbers, or numbers that we use every day to count the amount of items. So, numbers such as 1, 9, 10, and 18 are all natural numbers. It is also important to note that natural numbers do not have any decimal points. If, for example, if say I would have to count how many books there are in my room, I would go 1, 2, 3, 4 instead of zero point 0.1, zero point 0.2, and so on. So as such, natural numbers are known as counting numbers that do not have decimals. And they're represented by the notation n. So if you see this equation where it's like y with this e symbol and n, this basically means that y is a natural number. Next, moving on to whole numbers. So whole numbers are similar to natural numbers where there are no decimals. So numbers such as 0, 1, 9, 10, and 18 are all whole numbers. However, the difference between whole and natural numbers is that whole numbers have 0 in it. This means that a natural number is a whole number. As for example, if you were to take the natural number of 9, 9 is a whole number. But 0 is a whole number but is not a natural number. And as such, a whole number may or may not be a natural number. And a whole number is represented by the notation w. So again, if you see this equation, it simply means that y is a whole number. Moving on to, we can divide whole numbers into two categories, odd or even. So odd numbers are numbers that cannot be divided by 2, or in other words, when we try to divide that number by 2, it gives us a remainder of 1. And even numbers are numbers that can be divided by 2, meaning that when we try to divide the number by 2, it we get a remainder of 0. So now let's try to practice with the numbers 26, 9, 67, 4, and 0, and try to deduce whether each of these numbers are odd or even. So if you'd like to try any of these practices, just pause the video first and resume once you've got the answer. Alright, so 26. The first step to finding an odd or even number is to divide the number by 2. If we try to divide 26 by 2, we get the number 13 with the remainder 0. And as such, it can be divided by 2 and is a even number. Next, 9. If we try to divide 9 by 2, we get the number 4 and a remainder 1. Because we have a remainder, it means that the number cannot be divided by 2, and as such, it is an odd number. The same goes with the number 67, where if we try to divide that by 2, we get the result of 33 with a remainder of 1, meaning that it cannot be divided by 2, and as such, it is an odd number. 4 is an even number, because if we try to divide 4 by 2, we get 2 with a remainder of 0, which is even. And finally, 0. 0, when we divide by 2, we get the number 0, but the remainder of 0. Because we have the remainder of 0, it is an even number. So 26 is even, 9 is odd, 67 is odd, 4 is even, and 0 is also even. Next, we're moving on to integers. So integers are similar to whole numbers, where there are no decimals. However, a key difference between integers and whole numbers is that integers may contain negative numbers. So numbers such as negative 4, negative 6, 0, 1, and 7 are all integers. So, and as such, a whole number is an integer, as if we take a whole number 10, that is a integer. However, an integer may or may not be a whole number, because if we take an integer negative 4 is not a whole number, however, it is a integer. And integers are represented by the notation z. So watch out, it's not represented by I, but it is represented by z. Next, we're moving on to rational numbers. So rational numbers are numbers that can be expressed as a ratio of two integers, otherwise known as fractions. So a few examples of rational numbers is 1 over 2 or half. This is obviously a rational number because it is already explicitly in the form of a fraction. Now, what we're going to notice is that as we go on, these numbers are not fractions. However, they can be expressed or converted into a fraction. For example, 0.75, that can be converted into 75 over 100, and that is a fraction and thus it is a rational number. Next is 1. 1 can be converted to a fraction 1 over 1, which is also a rational number. And finally, 40%. 40% can also be converted into a fraction 40 over 100, which makes it a rational number. Now the question is, why is negative 3 over 4 a rational number? Notice how I said a ratio of two integers, meaning that a number can be negative. And as such, a fraction of negative 3 over 4 is still rational, because technically negative 3 and 4 are both integers, and they are expressed as a fraction. and rational numbers are represented by the notation q. So if you see this equation again, it simply means that y is a rational number. Next is irrational numbers, which is the opposite of rational numbers, where rational numbers are numbers that can be expressed as a ratio of two integers. Irrational numbers are numbers that cannot be expressed as a ratio of two integers, otherwise known as fractions. So a few examples of irrational numbers is the square root of 5, the cube root of 10, and the square root of 921. The reason why these are irrational numbers is because these numbers, when we express them, is going to be a never-ending decimal. And as such, we cannot express them as fractions. So to sum everything up, a real number can either be rational or irrational, and there's no in between. And there isn't a set notation for irrational numbers, but in some cases, a notation of p is used. So let's try a quick practice. Deduce whether or not these numbers are rational or irrational. So we have the numbers 1, pi, which is 3.14159, and so on. It's a never-ending decimal. 0.6231, 2 over 3, the cube root of 4, 0, the cube root of 56, the square root of 16, negative 2, the square root of 10, 4.39, and negative 3.5. So again, if you'd like to attempt this, just pause the video first and resume once you have your answer. Alright, so first, 1 is a rational number, as we can express 1 as a fraction of 1 over 1. Next is pi. Pi is actually an irrational number, because pi is a never-ending decimal, meaning that we cannot convert pi into a fraction, meaning that it is irrational. Next, 0.6231, we can convert that as a fraction of 6,231 over 10,000, which is the ratio of two integers, which is a fraction, which is rational. Next, 2 over 3 is already explicitly in the form of a fraction, meaning that it is a rational number. Next, the cube root of 4. The cube root of 4 is in the same case where it is a non-ending decimal, meaning that we cannot convert it into a fraction, meaning that it is irrational. And 0 is actually a rational number. It's actually a rational number because we can convert 0 into a fraction of 0 over anything. And because we can convert it into a fraction, that means that it is rational. The cube root of 56 is in the same case, where it is a never-ending decimal and such cannot be converted into a fraction. Now, the square root of 16 is a unique case because the square root of 16 is actually the same as 4. And 4 is a rational number because we can express 4 as 4 over 1. So in that case, the square root of 16 is actually a rational number, not irrational. Negative 2 is a rational number because we can express negative 2 as negative 2 over 1. The square root of 10 is a never-ending decimal, which means that it is irrational. 4.39 we can express as a fraction of 439 over 100, meaning that it is a rational number. And finally, negative 3.5 is also a rational number because we can express negative 3.5 as a fraction of negative 35 over 10. Next, we're moving on to prime numbers. So a prime number is a natural number that only has two factors, 1 and itself. Or in other words, a prime number cannot be divided evenly by any number except 1 and itself. And it is also important to note that prime numbers cannot be negative numbers because, again, it is a natural number, meaning that the scale ranges from 1 to infinity. Now let's look at a few examples of prime numbers here. So numbers such as 2, 3, 5, 7, 11, and 13 are all prime numbers. This is mostly because, let's take 5 for example. 5 only has two factors, which is 5 and 1, and that is the condition for a prime number. Now let's look at some examples that isn't a prime number. For example, 10. The reason why 10 isn't a prime number is because 10 can be expressed as four factors, being 1, 2, 5, and 10, as 2 times 5 is equals to 10. Because there are more than two factors, it means that 10 is not a prime number. But the question is 1 a prime number? The answer is no. 1 is not a prime number. Although yes, it is a natural number and it can be divided evenly by 1 and 1, the key note lies in only has two factors. The number 1 only has one factor, which is 1. Because for a number to be a prime number requires exactly two factors, 1 is not a prime number because it only has one factor. Next, we're moving on to common factors. So a common factor is a number that divides exactly into two or more numbers without leaving a remainder. Or in other words, it is a number that is a factor of a given number, for each given number. So let's look at the example for 24 and 30. The first step to finding common factors is to list down all the factors of each numbers. For example, in 24, we have the factors of 1, 2, 3, 4, 6, 8, 12, and 24. And for 30, we have the factors of 1, 2, 3, 5, 6, 10, 15, and 30. So the common factor is a factor where it can divide both numbers, meaning that a number that appears in both of the numbers. In this case, it is 1, 2, 3, and 6. And the highest common factor is simply the highest number from this set, which in this case is 6. So let's try a bit of a practice here. What are the common factors of 48 and 60 as well as their highest common factor? Alright, so the first step to finding common factors is always to list down the factors of each numbers. In this case for 48, it is 1, 2, 3, 4, 6, 8, 12, 16, 24, 28. And for the case of 60, it is 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. And the next step is to list down the factors that are the same for both numbers, which in this case is 1, 2, 3, 4, 6, and 12. And the highest common factor is simply to just find the highest common factor, the highest number from the set of common factors, which is 12 in this case. Next is common multiples, where the word common means the same thing as common factors. However, in this case, it is a number that is a multiple of two or more numbers. For the previous case, it was factors, and in this case, it's multiple. In other words, it is a number that can only be divided by each of the given numbers. So for example, multiples of 4 is 4, 8, 12, 16, 20, 24, and so on and so forth. And multiples of 6 is 6, 12, 18, 24, 30, 36, so on and so forth. So the common multiple is, again, finding the same number or the same multiple that appears in both numbers, which in this case is 12, 24, 36, and so on. And the lowest common multiple, otherwise known as the LCM, is simply the number that is simply the lowest number that appears in both in the set of common multiples, which in this case is 12. So again, let's try a bit of a practice. What are the common multiples of 6, 9, as well as their LCM or their lowest common multiple? The same step applies to common multiples, where we should list down all the multiples for each numbers. In this case, the number 6 is 6, 12, 18, 24, 30, 36, and so on and so forth. And 9 is 9, 18, 27, 36, and so on and so forth. So the common multiples of 6 and 9 are 18, 36, 54, or otherwise known as the multiples or the numbers that appear in both numbers. And the lowest common multiple, or the LCM, is the lowest number from this set, which is 18. Next, moving on to square numbers. So a square number, also known as a perfect square, is a number that is the product of an integer multiplied by itself. Or in other words, if a number can be written as n times n, otherwise known as n squared or n to the power of 2, where n is a whole number, then it is a square number. So a few examples of square numbers are 4, which can be expressed as 2 times 2 and as such is a square number, 16, which can be expressed as 4 times 4, which in this case is a square number, and 9, which can be expressed as 3 times 3, which is a square number. Now again, let's try a bit of a practice here. Are these numbers square numbers? 27, 25, 1, and 8. So in the case of 27, it is not a square number because it cannot be expressed or written as n times n. A simple way to check this is if we take the square root of 27, we do not get a whole number. 25, however, is a square number, as we can express 25 as 5 times 5. 1 is also a square number, as we can express 1 as 1 times 1. But 8, however, is not a square number, because we cannot express 8 as n times n. Next are cube numbers. So these are also called perfect cubes, and it is a number that is a product of an integer multiplied by itself multiplied by itself twice. Or in other words, a cube number can be written as n times n times n, otherwise known as n cubed, where again n is a whole number. So a few examples of cube numbers are 8, which can be expressed as 2 times 2 times 2, 27, which can be expressed as 3 times 3 times 3, or 125, which can be expressed as 5 times 5 times 5. Alright, so again, let's try a bit of a practice. So are these numbers cube numbers? We have 64, 32, 1, and 99. So the number 64 is actually a cube number because we can express 64 as 4 times 4 times 4. And an easy way to check if it is a cube number or not is we put the number through a cube root. If we get an integer or a whole number, then that is a cube number. 32, however, is not a cube number because it cannot be expressed as an integer multiplied by itself twice. Or when we try to cube root 32, we don't get an integer. 1 is also a cube number, so 1 is both a square number and a cube number because 1 can be expressed as 1 times 1 times 1, which is the property of a cube number. And 99 is not a cube number because if we try to cube root 99, we do not get an integer. So that'll be it for today's mathematic lesson from LearnIt with the topic of numbers and number theory. And yeah, I hope you guys found something new from this lesson or at least find it useful. And yeah, thank you for watching today's lesson and we're gonna see you in the next one.